Welcome to all. I am Parthiban. In this video, going to discuss about steam cogeneration. The gas turbine cogeneration systems is shown as schematical diagram. In the schematic diagram, showing that the major components and what are the process will be involving in the gas turbine cogeneration system. The left hand side, the cooling tower, condenser and steam turbine is located near the exhaust and the water pump area, and then the compressor and the turbines combine together, and the fuel combustion chamber also located near the compressor and the turbine. The intake air passes through the compressor. At the exit of the intake air will be entering into the fuel compressor through compressor. After that, the fuel compressor will be enter into the inlet of turbine, and that exit of turbine will enter into the heat recover steam generator. After that, it will be exhaust. The turbine rotating shaft connected with generator. The generator is producing electricity when the turbine started to rotate. This is the power generation cycles. Also, the cooling cycles will become the top portion. The cooling tower is located near the condenser. The condensate water will be flowing into the cooling tower. In that way, the circulating of water from condenser to steam turbine and steam turbine to heat recover steam generator. Through that, the gas turbine cogeneration system will be achieved. Cogeneration system means the system which is involving to achieve the high efficiency or overall high efficiency. Gas turbine cogeneration systems can produce all or a part of the energy requirement of the site, and the energy release at high temperature in the exhaust stack can be recovered for various heating and cooling applications. Though natural gas is most commonly used, other fuels such as light fuel oil or diesel can also be employed. The typical range of gas turbines varies from a fraction of a megawatt to around 100 megawatt. Gas turbine cogeneration has probably experienced the most rapid development in the recent years due to the greater availability of natural gas, rapid progress in the technology, significant reduction in installation costs, and better environmental performance. Furthermore, the gestation period for developing a project is shorter, and the equipment can be delivered in a modular manner. Gas turbine has a short start-up time and provides the flexibility of intermittent operation, though it has a low heat to power conversion efficiency. More heat can be recovered at high temperatures. If the heat output is less than that required by the user, it is possible to have supplementary natural gas firing by mixing additional fuel to the oxygen-rich exhaust gas to boost the thermal output more efficiently. This is schematic diagram of gas turbine cogeneration, and this is a simple view of the cogeneration system. Here the steam is supplied at boiler top portion. At the bottom of the boiler will have water content. The flue gas passed from gas turbine outlet, and then the flue gases enter into the boiler. Because of the flue gas heat, the boiler tube will catch the heat from the flue gas, and then the water will converted into steam. The steam is circulated to the turbine unit, and then that remaining portion of the flue gases will be exhausted through the exit of the boiler. In generally, the fuel air supply into the gas turbine, the exit of the gas turbine will provide the flue gases at 500 degrees Celsius. Because of the gas turbine, the generator can able to generate electricity, as well as the exhaust flue gas also used to generate the steam through boiler, so that this is a cogeneration with a gas turbine system. The reciprocating engine cogeneration systems. These cogeneration systems have high power generation efficiencies in comparison with other prime movers. There are two sources of heat for recovery: exhaust gas at high temperature, engine jacket cooling water system at low temperature. As heat recovery can be quite efficient for smaller systems, these systems are more popular with smaller energy consuming facilities, particularly those having a greater need for electricity than thermal energy and where the quality of heat required is not high. Example: low pressure steam or hot water. Reciprocating engine cogeneration system. Here, the reciprocating engine is located near the generator. The generator also coupled with the reciprocating engine shaft, and the lubricating oil cooler will be entering and exiting through the lubricating unit, and jacket water cooler also located near the reciprocating engine. Charge air cooler also entering and exiting from the reciprocating engine, as well as heating load. The fuel is supplied into the reciprocating engine, then the generator can able to produce the power load, as well as HRSG unit will generate heating load, and then again the heating load is supplied into that HRSG. After the flue gas will exhaust from the HRSG unit. In order to the reciprocating engine cogeneration system is working. Though diesel has been the most common fuel in the past, the prime movers can also operate with a heavy fuel oil or natural gas. These machines are ideal for intermittent operation, and their performance is not as sensitive to the changes in ambient temperatures as the gas turbines. Though the initial investment on these machines is low, their operating and maintenance costs are high due to high wear and tear. Exhaust. Here the IC engines located at the bottom, as well as the cooler unit located near the IC engines. Oil, air and water supply through the IC engine system, and then the boiler also connected with the IC engines chamber. In order to the exhaust heat supply into the boiler, and the heat also for generating the steam by supplying the boiler water. Finally, the flue gas exhausts at the exit of boiler. This process will be continuing through the condenser unit, and again it will enter into that oil, air and water chamber of IC engine. Again steam is generated at hot water, and the process cycle will be continuing. Within this, I will conclude this presentation, and the continuation will become the part 4. Thanks for watching.